time stream using some models to impute missing data in Uniform Crime Report data published by the Federal Bureau of Investigation. Last time I left off, I had identified that there are sort of 4 patterns of missingness in this data. And I'm using the RStudio Notebook feature here. Really handy. 4 patterns of missingness are quarterly reporting, biannual, and annual reporting. Really interested in making sure that these types of reporting can be spread out over the monthly reporting that most agencies tend to do. So that's what I'm interested in doing there. My tune's going. So for the next 30-40 minutes, that's what I'm going to be working on. Key here is to look at how we can parameterize month. So when we estimate the total report that the agency reported, we can proportionally allocate the total to the different months of the agency's report. So I have this basic model that I fit, and I see that it's really wrong because it's got these big spikes for December and June. So that's saying that a lot more crime should be allocated in December and June. No reason that it should be, 5 times greater or 10 times greater than other months. And in fact, if we look at the data visually, which we can look at up here earlier in my notebook, we see big spikes, but the reason we see those big spikes is likely because of the irregular reporting period. So now I need a way to identify annual, biannual, quarterly reporting patterns. Earlier, previous stream, I talked about December being when it looks like annual reporting is most likely. So now I want to look for when people do June reporting along with December reporting. So I'm going to see if I can make a variable here that identifies when the only 2 fields for an entity with data in them are in June and December, and everything else is a 0. So we're going to use some group by magic here. And we're going to calculate a variable called December June flag, which equals this is the conditional statement here, should a comma. The problem is I don't think that'll work. I think that's going to give me the wrong thing. check. Well. We look at this, then we see that the months are not so far out of whack with each other. These parameter estimates aren't wildly out of control. Let's just take a peek at them here. Better format. So we see it's all relative to April, which isn't really ideal, but we're not here to interpret these, nor do we think that this is the true model. We're just trying to square away a way to more fairly allocate crimes across months when we know for sure that they haven't been. These two should not both ever be true. And indeed, that's the case. They're never both true. So they're tackling different things. Let's look at an observation where this is true to see if whether or not we're really doing the right thing. So let's filter where let's make only places with population. Yeah, that's not right. We should see a bunch of December and Junes with data and not September's. So this entity reported data in lots of different months. It's still getting flagged. So this if statement is not correct. So we need to go back and modify this to get our flag. Alright, now we're trying to hone in on this. Let's narrow down the field so it's easier to read there. It's a little hard to see what I'm looking at. Don't know how to sample object. There you go. Okay, so you don't like that select statement. It's the pipe. December, December. December. Seem to be picking up places with June data. Without June data, which is really not what I'm looking forward to doing. So let's look back at our logical statement. Sum of all the months that aren't June and December is equal to 0. Now we probably need to say and they report something in June. June and December. These guys report nothing. June and December. Now we're getting just June. Now we have to also do June. It's tricky. The independentness for each of them, which is not hard to add here. Let's change this to December. And we should have our biannual reporters of those that reported any data. Take the group by out. Just arrange this. December and June. Oh, how many rows do we have that meet this criteria, which now looks correct? 336. Not that many. But can probably see that we're better off having put that in. Let's see what our June flag is. It's correct. Convert this to numeric. Luckily, since I made it illogical, it's actually pretty easy. Man, this is a great opportunity to use the double pipe, which I love. After we take that out, Sue might have a seasonal effect here. Or the quarterly reporting might still be existing. November, October, September. We'd expect the quarterly report in May or April. July or June. But for now, I think we can probably safely project these coefficients, because the quarterly reporting we already saw is going to be pretty rare. So, we can actually apply this to the cases where there is the flag. And The way to do it in a pipe is a little tricky, but try it out here. First thing we need to do is do that mutate statement up there that we already did. Here, just copy this thing. Now let's take out the cases that we want to project. Oh yeah, we're gonna use filter. And we're gonna filter where any of these flags equals 1. What does that give us? 628 observations. 54 separate agencies. Oops, never table unique. Table unique. Yeah, we got a lot of different years represented. Remember, this is just a sample of the full data, so we're just getting this to work right. So let's see if we can just say, predvals fitted gets predict simpmod. So there's our fitted values. And what are we fitting? We were fitting which has much more zeros. So let's just quickly plot these two together. They were shifting things down from where they were. Actually, we're shifting them up. Oh, we might not have all the months here. That would be really frustrating. Because why? The December flag is fit per month, flags are not. June and December flag, we actually want entire trajectory. That explains it. So we actually need to see. Just sum the flags. Yeah. Before ORIs. Oh. Tons more zeros getting adjusted. Always adjusting down, that's what we want to see. Always adjusting down. Let's make this a little cleaner for posterity. I always like the black and white theme. Just it's probably more intuitive to flip them around. That. Then we need this. That in illuminating of a graph, but just move forward. Let's just look at some data. So for this ORI, 1998, they reported 794 in December. Spread that out, these amounts. roughly 64 a month, but we can see that the February gets a bigger decrease. So does November. That's kind of what we want. Now what we need to do is first round it off and give it a floor. Less than 0, set it to 0, else return the normal value. There we go. Now we just need to merge it back on. And then we need to make this method more generalizable so we can use it for all of the possible fields. And make it, a function basically that we can then trend all of these for all of these possible variables. That'll be a little tricky, but we can probably do the replacement in the pipe. Let's see if we can. Now we'll just say do a last mutate, which is that. Is there a replace verb in dplyr? Nope. I'll just create a copy here. Alright, so it didn't like that. Let's try to ungroup it first. Now we've only returned the filtered. That can work. It's a little transformation to it. Nice. Try to get it back to the same shape. See if these are identical. Then I can just bind them pretty easy using bind rows. Not the same. Let's drop that. False. Missed a match. What do we got going on here? Top 10 and 12, I guess. They should be true. Boom. Great. Okay. Let's just see if this works. That works. So let's get bind rows. This bad boy. 2. Not gonna today. Oh yeah, this is not a data frame. This is. And now we've imputed it. So the next steps is to functionalize this work so that it can be applied column-wise to all of the different variables here. And the offenses can be spread out that way. It's going to run into some particular tricks around low-incident offenses, and I'll have to work it out. So that'll be some work tomorrow. But for now, we interpolate different levels of missingness in the crime data. It's pretty great to be able to do. So that'll conclude the stream for today, but see you soon. See you again. Later.